Okay, this video is on the area of regular polygons. Sorry, the sound's not going to be my best today. So what we're trying to do is find what do we mean by a regular polygon, I guess is the first thing we want to understand. And a regular polygon means that all of the sides are congruent and all of the angles are congruent. So there's a regular polygon. Here's a regular polygon as long as they're all congruent. So you're going to notice that you're going to have a lot of shapes that are the same each time when you have regular polygons. All right, so regular means that all the sides are the same and all the angles are congruent. So we can use this formula. You might remember the number of sides minus 2 and multiply that by 180. That's how you can find the sum of the angles in a polygon. So hopefully that'll come right back to you, but let's kind of just talk about this. First of all, you want to write this down. The radius is the distance from the center to a vertex. The distance from the center to the vertex. So let me show you that. This is a radius to a vertex, and here's a vertex obviously, and this is a radius. So radiuses go to the vertex from the center, and the other thing, what are these down here? What do we got? These are possums, and I'm showing you possums from the beloved movie Bambi because, oh, that's cool. That's very cool. I like doing that. I'm showing you these because this right here is called the apothem. And I'll use a different color to show you the apothem. And that goes to a 90 degree. So it's kind of like the altitude, I guess you could say. The apothem goes to the center at 90 degrees on the other side. So you're going to want to write down that it's the perpendicular distance from the center to a side. Perpendicular distance from the center to a side. So what's important about this whole setup is that if you look at this diagram, what do you notice about these triangles here? You have a triangle, like let's say you have a triangle here. Okay, we'll call that T1. Well, what do you notice about all of these triangles? 2, 3, 4, 5, these 6 triangles.
Matt Lorian, please come to the main office. Matt Lorian.
Okay, sorry, was interrupted and kind of forgot what I was talking about, but presumably if you could just find the area of this triangle, right, just the area of this triangle, which is 1/2 base times height, and then if you took that area and you just multiply that by 6, because there's 1, 2, 3, 4, 5, 6 of these, right, then you'd have the area of that entire shape. So hopefully that makes sense. And the apothem is going to be pretty important because the apothem is the height, really, right? The height of that triangle. That's important. And the base, I guess, is just the side of the shape. So hopefully that helps. Let's move on. Let's try one. All right, so let's just talk about how we find angle measures in the shape. So hopefully you can remember that this is a 5-sided figure, so we're going to take 2 from that, which is now going to be 3, and multiply that by 180. That's going to be the total sum of the degrees here. So 3 times 180, that's going to be, let's see, 540. Okay, I should have known that. But it's 540 anyways. So the total degrees is 540, and there's 1, 2, 3, 4, 5 angles. So we divide that by 5. This is a review, and that is 108, 108. So each one of these angles is 108, 108, 108, 108. I'll just put that in there. And I guess what you could say now is that this angle here, 3, is cut in half. So that would be 54 degrees. And if that's the case, if 3 is equal to 54 degrees, then what is the measure of angle 2? Well, then 2 is triangle sum, right? So we have 90 here plus the 54 here, and then the 2, the angle 2, whatever that is. So we have a triangle going on here is what I'm trying to say. So that adds to 180, so we're going to basically have, I think, 36 would be the angle for 2. What would angle 1 be? Angle 1. How can we figure that out? Let's think about that for a few moments. Let's get rid of these triangles. If you think about it, we got angle 1, which is this angle, and there's 1, 2, 3, 4, 5 of these same angles inside of that rotation. Well, how long does it take to rotate one time around? How many degrees is one full rotation? Think about like doing a 540 or something on a skateboard or whatever else you would do. I don't know. A whole rotation is 360 degrees, so we could say that angle 1 would equal 360 divided by, because there's 5 different angles, divided by 5. And that would make the angle 1 equal to 72 degrees, which, by the way, is half of 36, because angle 2 is, these are cut in half as well. So hopefully I have not like blown your mind with this, but there's a lot going on in this diagram. And if you just break it down slowly and you know your triangle sum and you can remember this formula pretty well right here, then I think you're going to be fine. One new bit of information might be that a whole rotation is 360 degrees, and there's obviously different ways you can get the answer, so that's something to be aware of. Okay, so I'm going to make this a now you try. I didn't write it on your note handout, I don't think, but let's write now you try. And why don't you try to figure out these angles? This is a portion of an octagon, so there are 8 different sides here. These are 4 of the 8 sides. And we want to figure out what the measure of angle 1, angle 2, and angle 3 are. Okay, so that's your job. Pause the video and try to figure out those 3 angles. Take your time, slow and steady, see the example before. Alright, so we are on to another one now, and we're going to try to figure out actually the area of this shape. So if you think about it, you can kind of think of it almost like a pizza. This is actually, I think this is maybe even an octagon. No, it's not. It's a 10-sided figure, isn't it? So all of these sides are 8, and what we really want to understand is what is going on with this triangle. How can we figure out the area of that triangle? Well, if this is T, right, the area of that triangle is 1/2 of 8 times 12.3. I believe that said 12.3. Let's make sure, yep, 12.3. So that is what we need to use to find the area of this blue triangle. So that's 12.3 times 4. Something makes me think I've done this wrong. No, I think I'm good. 49.2. So the area of this triangle is 49.2. So the triangle, the area of the triangle equals 49.2. But now, how many triangles do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 triangles. So really we just have to take 49.2 and multiply it by 10. And if we do that, we have 492. And that would be the area of this entire shape. This was in units of inches, by the way, so I have kind of, I do kind of owe you an inches squared here. It's 492 inches squared because we are finding area. And if you think about it, right, what's kind of important is that this is 8 inches times 12.3 inches, and inches times inches is inches squared. So a lot of people don't realize that with like unit analysis. It's really that you're multiplying inch by inch, and that actually multiplies to inches squared. That's something you have to realize. So let's try to find some measured angles again. All right, so what do we got? Find the measure of the numbered angles. Well, I would say here that these are all 60, right? Because this is a regular polygon. They're all the same, equilateral, equiangular. So those are 60. So angle 3, the measure of angle 3 is equal to 30 degrees. The measure of angle 2 is equal to, well, if 3 is 30, then that would be a 60. It's a 30, 60, 90, it looks like. And now the question becomes, if this is angle 2, right, if this here is 60, what is this whole entire thing? I believe it's going to be 180, because this is double. Now 1 is double, so the measure of angle 1 is 180 degrees. Now another way of doing that is to understand that these three are congruent to each other. 1, 2, 3 angles. Shouldn't have made them line up so nice, but these are the three angles. They're congruent to each other. And this whole rotation is 360. If you take 360 and divide by 3, you have, that's 120. Oh yeah, so I've done some math wrong here. So hopefully you might have already caught that. 60 doubled is not 180. 60 doubled is 120. So it's good that there's two ways of getting angle 1, because I was wrong the first time. 60 would be doubled to get the angle 1. So that's 120 degrees. So that's what's happening here. We're almost to the end. So let's see. Here's another thing that could just be helpful to write down. If you want to write it down, great. It's really a trick, and it's not something that I use much. The apothem is in blue right now. The perimeter of this shape is in green. So if you took the whole perimeter of the shape, multiplied it by half of the apothem, you would have the area of the polygon. And that kind of basically has to do with you're taking the base every single time. You're doing 1/2 base times height, right? And you're just using the perimeter for your base, because you're having 5 different bases of 5 different triangles in this shape. So hopefully that makes some sense to you. This would be broken into 5 would this be broken into 5 triangles? 1, 2, 3, 4. This is kind of interesting. I'm kind of psyching myself out here a little bit. Oh, there we go. Yeah, it would be 5 triangles. Okay, I don't know what was wrong with me. I was looking at it differently. So this would be 5 different triangles, and instead of just doing that and multiplying by 5, you could just do the perimeter. So the perimeter will give you all of those bases added up, and you multiply by half of the height, which is the apothem. So 1/2 apothem times perimeter, not a formula I'm going to memorize, but if you want to memorize it, that's fine. All right, so we'll do one more. Find the area of the regular polygon. So here's this shape again, and I am going to try to figure out, I don't know, there's a lot of different ways you could do this, but the way that I'm going to try to do it is I'm just going to say, okay, this here is 60, obviously, and this is now 30. And if that's the case, that 8 inches is now going to show me that this is 4 inches, and this is 4√3 inches. So I guess I could just do my old 1/2 base times height to get through this area. And so my area would equal, let's see, 8√3 inches squared. Remember, that's because this is 4 inches, and this is 4 inches, and inches times inches is inches squared. So that is the area of this triangle. I did that one by a different way. I didn't use the apothem per se. I just found it to be a little easier. Another option you would have had, and I'm not going to go through the whole thing, but I'm just going to show you a little bit, is to kind of just take the center of the shape and draw in your apothems if you'd like. But I don't even know that you're going to know what those are. Oh, that's... Nah. Yeah, I don't think it's going to work too well with this type of shape. So, anyhow, let's not do it that way. Forget I said that. Moving on, we got this last one right here. It's a now you try, It's the area of a regular hexagon. I want you to try to find the area of this hexagon. It's regular. All the angles are the same. All the sides are the same. Good luck, and get that done. Make sure you have nice, diligent notes, and I will see you in class.